Ever wondered what mysteries lie beyond the blue horizon of Neptune? From its supersonic winds to its hidden ocean of liquid water, this distant giant planet is full of astonishing surprises. Neptune, the eighth planet from the Sun, remains one of the most enigmatic members of our solar system. What makes it so unique, and why does it capture our imagination? Join us for an incredible journey into the heart of Neptune's wonders, where science meets the extraordinary in a world of blue. Neptune is a windy wonderland. Neptune is a planet of extremes, and its winds are no exception. This gas giant holds the title for the fastest winds in the solar system, with speeds reaching up to 1,200 miles per hour. That's nearly 5 times faster than the strongest hurricanes on Earth. These incredible winds create a dynamic and chaotic atmosphere, with giant storms and dark spots moving across the planet's surface. The planet's winds are fueled by Neptune's internal heat, which radiates more energy than it receives from the Sun. This heat drives massive convection currents, creating powerful jet streams and vortices that rage across the atmosphere. These winds give Neptune its ever-changing weather patterns, despite its frigid distance from the Sun. One of the most famous weather features on Neptune was the Great Dark Spot, a storm system the size of Earth. Discovered by the Voyager 2 spacecraft in 1989, this giant storm vanished just a few years later, showcasing the dynamic nature of Neptune's atmosphere. Scientists are still studying what makes Neptune's winds so extreme. The planet's unique combination of internal heat, atmospheric composition, and rapid rotation all play a role, but the exact mechanisms remain a mystery. The winds of Neptune are a testament to the raw power of planetary weather, offering a glimpse into a world where nature reigns supreme. The deep blue mystery of Neptune's color. Neptune's striking blue color is one of its most defining features, but it's not just a simple reflection of the sky. This rich azure hue comes from methane in the planet's atmosphere, which absorbs red light from the Sun and reflects blue light back into space. However, methane alone doesn't fully explain Neptune's intense coloration. Scientists believe that there are other, unknown components in the atmosphere that enhance the blue tone. These mystery molecules have yet to be identified, making Neptune's appearance as much a scientific puzzle as it is a visual marvel. Neptune's vivid blue sets it apart from its neighbor Uranus, which also contains methane but appears a paler shade of blue-green. The subtle differences in atmospheric composition between these two planets highlight just how unique Neptune truly is. The planet's color isn't just an aesthetic feature, it provides valuable clues about the composition and chemistry of its atmosphere. By studying Neptune's blue, scientists gain insights into the processes at work on this distant world, and even on exoplanets that share similar characteristics. Neptune's mesmerizing blue reminds us of the beauty and complexity of our solar system, where even the color of a planet holds untold secrets. The discovery of Neptune was a mathematical marvel. Neptune's discovery in 1846 wasn't a stroke of luck, it was a triumph of mathematics and astronomy. Scientists noticed that the orbit of Uranus wasn't following predictions, suggesting the gravitational pull of an unseen planet. Using calculations, French mathematician Urbain Le Verrier pinpointed Neptune's position without ever looking through a telescope. When German astronomer Johann Galle aimed his telescope at the predicted spot, Neptune was there, just as Le Verrier had calculated. This marked the first time a planet was discovered through mathematical prediction rather than direct observation, a breakthrough that changed the course of astronomy. Interestingly, English mathematician John Couch Adams had also made similar calculations around the same time, leading to a controversy over who deserved credit for Neptune's discovery. In the end, both Le Verrier and Adams are recognized for their contributions. Neptune's discovery also underscored the power of Newton's laws of motion and universal gravitation, which formed the basis of the calculations. This event cemented the idea that mathematical models could predict the existence of celestial objects, a concept that continues to guide modern astronomy. The discovery of Neptune stands as a testament to human ingenuity, showing how the mind can uncover worlds hidden from the eye. Neptune's rings are thin and wispy. Neptune is adorned with a set of faint, thin rings that add to its otherworldly charm. These rings, made of dust and ice particles, are far more delicate and less prominent than those of Saturn. There are 5 main rings: Gale, Le Verrier, Lassell, Arago, and Adams, each named after notable scientists who contributed to our understanding of the planet. What makes Neptune's rings unique is their clumpy and uneven distribution, a phenomenon scientists are still trying to understand. Some parts of the rings appear brighter and denser, forming arcs rather than smooth, continuous bands. These arcs are thought to be stabilized by the gravitational pull of Neptune's moons, particularly Galatea. The rings were first detected in the mid-1980s through ground-based observations and were later confirmed by the Voyager 2 spacecraft. Voyager's flyby provided detailed images of the rings, revealing their complex structure and composition. Despite their faintness, Neptune's rings hold valuable information about the planet's history and the processes that shaped its outer regions. By studying the rings, scientists hope to uncover clues about the formation of the outer solar system and the interactions between moons and planetary rings. Neptune's rings may not be as famous as Saturn's, but they are a delicate reminder of the intricate beauty found throughout the cosmos. Neptune is an ice giant with a hidden ocean. Neptune belongs to a category of planets known as ice giants, which are distinct from gas giants like Jupiter and Saturn. Beneath its thick atmosphere lies a mantle of water, ammonia, and methane ice, creating an interior vastly different from the gas giants. This icy composition gives Neptune its classification, but it also raises intriguing possibilities. Scientists believe that under the icy mantle lies a vast ocean of superheated high-pressure water. This ocean, kept in a liquid state by extreme pressure, could potentially harbor exotic forms of life or unusual chemical processes. Neptune's core is a rocky mix of silicates and metals, surrounded by this mysterious ocean. The transition from the icy mantle to the core is gradual, creating a layered structure that adds to the planet's complexity. The pressure and temperature in Neptune's interior are so extreme that methane molecules could break apart, forming diamonds. These diamonds might sink to the core, creating a glittering layer of solid carbon, a phenomenon often referred to as the diamond rain. Neptune's status as an ice giant with a hidden ocean sets it apart as a planet full of surprises, challenging our understanding of what a world can be. Neptune's moons are a diverse family. Neptune is home to 14 known moons, each with its own unique characteristics. The largest and most famous is Triton, a fascinating moon with a retrograde orbit, meaning it orbits Neptune in the opposite direction of the planet's rotation. This unusual motion suggests that Triton was likely captured from the Kuiper Belt, a region of icy objects beyond Neptune. Triton is a world of wonders, featuring geysers that spew nitrogen gas, a thin atmosphere, and a surface covered in frozen nitrogen and methane. Its geologically active surface makes it one of the most intriguing moons in the solar system, and a prime candidate for future exploration. In contrast to Triton's icy splendor, Neptune's smaller moons are less dynamic but no less interesting. Proteus, the second largest moon, is oddly shaped and heavily cratered, suggesting it has remained relatively unchanged for billions of years. Nereid, another notable moon, has one of the most eccentric orbits of any moon, swinging dramatically closer and farther from Neptune. These moons offer a glimpse into the diverse processes that shape planetary systems. Some moons are likely remnants of Neptune's original satellite system, while others, like Triton, are later additions. Studying them helps scientists understand how moons form and evolve over time. Neptune's moons are a microcosm of the solar system's complexity, each contributing to the rich tapestry of this distant planet. Neptune's magnetic field is misaligned and tilted. Neptune's magnetic field is unlike any other in the solar system. It's both off-center and tilted at a staggering 47 degrees relative to the planet's rotational axis. This means that Neptune's magnetic field is constantly shifting, creating a wildly dynamic magnetosphere. The magnetic field is generated by electric currents within the planet's icy mantle, rather than in a metallic core as on Earth. This difference in origin contributes to its unusual properties, including its irregular shape and strength. In some regions, Neptune's magnetic field is up to 10 times stronger than in others. This chaotic magnetic field produces spectacular auroras, much like the northern and southern lights on Earth. However, Neptune's auroras are more scattered and less structured, appearing as patches of glowing light near the poles. The planet's unique magnetosphere also interacts with the solar wind in ways that are still not fully understood. Voyager 2 provided the first glimpses of Neptune's magnetic behavior, but many questions remain about how it affects the planet and its surrounding space environment. Neptune's magnetic field adds another layer of intrigue to this distant world, highlighting the diverse ways planets generate and sustain magnetic forces. Neptune's year lasts 165 Earth years. A year on Neptune is an extraordinary 165 Earth years long, meaning it takes nearly 2 centuries to complete one orbit around the Sun. Since its discovery in 1846, Neptune has completed just one full orbit, which occurred in 2011. This lengthy year is due to Neptune's vast distance from the Sun, about 30 times farther than Earth. At this distance, the Sun appears much smaller in Neptune's sky, providing only a fraction of the light and warmth that reaches our planet. Despite its slow orbit, Neptune rotates rapidly on its axis, completing a day in just 16 hours. This rapid spin, combined with its elliptical orbit, creates fascinating seasonal variations. Each of Neptune's 4 seasons lasts more than 40 Earth years, resulting in gradual but significant changes in atmospheric activity. Understanding Neptune's lengthy year and slow seasonal shifts provides valuable insights into the dynamics of planetary orbits and climate systems. The planet's orbit also places it in a region of the solar system that offers clues about the formation of outer planets and the migration of celestial bodies. Neptune's epic year serves as a reminder of the vast scales of time and distance that define the outer reaches of the solar system. Neptune was the last stop for Voyager 2. In 1989, NASA's Voyager 2 spacecraft became the first, and so far only probe to visit Neptune. This historic flyby provided humanity's closest look at the distant planet, revealing breathtaking details about its atmosphere, moons, and rings. Voyager 2 captured stunning images of Neptune's vibrant blue clouds, powerful storms, and faint rings, transforming our understanding of the planet. It also made groundbreaking discoveries, such as the presence of the Great Dark Spot, the dynamic weather patterns, and Triton's geysers. The spacecraft's instruments measured Neptune's magnetic field, confirming its tilted and off-center configuration. Voyager 2 also provided data on the planet's temperature, wind speeds, and atmospheric composition, laying the foundation for future studies of ice giants. Voyager 2's flyby lasted only a few hours, but its legacy endures. The mission's data continues to inform scientific research and inspire new questions about Neptune and its role in the solar system. The encounter with Neptune marked the end of Voyager 2's planetary tour, but the spacecraft remains a symbol of humanity's quest for knowledge, now traveling through interstellar space as a messenger of discovery. Neptune may hold clues to the formation of exoplanets. Neptune's status as an ice giant makes it a valuable analog for studying exoplanets, planets beyond our solar system. Many of the exoplanets discovered so far are Neptune-like in size and composition, falling into a category known as mini-Neptunes or sub-Neptunes. By studying Neptune, scientists can better understand the atmospheric processes, magnetic fields, and interior structures of these distant worlds. Neptune's dynamic weather, deep blue hue, and icy mantle offer a template for modeling the conditions on similar exoplanets. One of the most intriguing aspects of Neptune-like exoplanets is their potential habitability. While Neptune itself is inhospitable, its characteristics help researchers identify which exoplanets might have liquid water, stable atmospheres, or conditions suitable for life. Future missions to study Neptune up close, such as orbiters or atmospheric probes, could provide critical data for interpreting observations of exoplanets. These missions would also deepen our understanding of how planets like Neptune form and evolve in different stellar systems. Neptune's connection to exoplanet research highlights its importance not just as a member of our solar system, but as a key to unlocking the mysteries of the universe. Neptune is a planet of mysteries, extremes, and beauty, offering a glimpse into the farthest reaches of our solar system. From its supersonic winds to its hidden ocean, Neptune continues to captivate scientists and dreamers alike. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the wonders of the universe with us.
Did you know that beyond Neptune lies a mysterious region of space that holds the keys to understanding the origins of our solar system? The Kuiper Belt, often overlooked, is a treasure trove of icy worlds, hidden secrets, and cosmic enigmas. What lies within this vast expanse, and why is it so vital to the story of our universe? Join us on this cosmic journey as we reveal 7 little-known facts about the Kuiper Belt, unraveling its mysteries one by one. The Kuiper Belt is home to Pluto and other dwarf planets. The Kuiper Belt is a vast icy expanse beyond Neptune, home to some of the solar system's most intriguing small worlds. Among these is Pluto, the famous dwarf planet that continues to captivate us despite its reclassification. The Kuiper Belt is a treasure trove of rocky and icy remnants from the solar system's early days, holding secrets about planet formation. Alongside Pluto are other fascinating dwarf planets like Haumea, Makemake, and Eris, each with unique characteristics. Pluto, for instance, is a dynamic world with icy mountains, smooth plains, and evidence of past glacial activity. Its largest moon, Charon, is so massive relative to Pluto that the pair are often called a double dwarf planet system. Haumea stands out with its elongated football-like shape, caused by its rapid rotation. Makemake, with its bright, reflective surface, shines prominently in the Kuiper Belt. Eris, nearly as large as Pluto but much farther out, played a key role in redefining Pluto's status as a dwarf planet. These icy worlds defy expectations, revealing active surfaces, diverse atmospheres, and complex orbits. They challenge our understanding of how celestial bodies evolve over time. Far from being a static region, the Kuiper Belt is an evolving frontier, brimming with surprises. Each new discovery reshapes our perspective of the solar system and its history, showcasing the rich diversity of these distant objects. The Kuiper Belt serves as a reminder that even the farthest reaches of our solar system hold mysteries waiting to be unraveled. It's a relic of the early solar system. The Kuiper Belt isn't just an icy region in the distant reaches of our solar system, it's like a time capsule from the very beginning of everything. Picture this. Over 4.5 billion years ago, our solar system was just a swirling disk of gas and dust. While planets like Earth, Jupiter, and Neptune formed from that material, not everything got used up. Some of it stayed behind, untouched and frozen in time, way out past Neptune. That leftover material is what makes up the Kuiper Belt, a snapshot of the solar system's chaotic infancy. What's so incredible about the Kuiper Belt is that it contains some of the oldest and most pristine objects in the solar system. These icy bodies, untouched by the sun's heat or planetary collisions, are like fossils, holding clues about the building blocks of planets and the processes that shaped our cosmic neighborhood. Scientists believe studying them offers a backstage pass to the solar system's origin story, showing how everything came together billions of years ago. One reason the Kuiper Belt is a hot topic in astronomy is its insights into planetary formation. The objects, called Kuiper Belt objects, KBOs, range from a few miles across to nearly the size of Pluto. By analyzing them, scientists unravel how planets grew from tiny particles into complex worlds and study the chemistry of the materials present when the solar system was just forming. What makes the Kuiper Belt even more exciting is that it's not unique. Similar belts have been found around other star systems, suggesting these regions are a universal feature of planetary formation. By exploring the Kuiper Belt, we're not just learning about our own solar system, we're uncovering patterns that apply to planets across the galaxy. The Kuiper Belt serves as both a time capsule and a bridge to understanding the universe, connecting our solar system's story with the larger narrative of planetary systems everywhere. It's a reminder that even the most distant regions of space hold the keys to unlocking our cosmic origins. Preserved in ice and rock, the Kuiper Belt offers an unparalleled glimpse into the universe's ancient history. The Kuiper Belt is vast and mysterious. The Kuiper Belt is one of the most fascinating yet mysterious regions in our solar system. Imagine a gigantic, donut-shaped zone filled with icy objects stretching far beyond Neptune. Spanning billions of miles, this vast frontier remains largely uncharted despite our advances in space exploration. Even though much of the solar system has been mapped, the Kuiper Belt feels like an unsolved puzzle waiting to be decoded. This icy expanse is home to countless objects, from tiny fragments of frozen debris to massive dwarf planets like Pluto and Eris. Scientists believe we've only scratched the surface of what's out there. While a few thousand Kuiper Belt objects, KBOs, have been identified, there may be hundreds of thousands, or even millions of these icy worlds scattered across this region. Each KBO is a time capsule, preserving unique secrets about the early solar system and forming part of an extraordinary cosmic tapestry. Studying the Kuiper Belt is no easy feat due to its incredible distance, faint light, and the cold, dark vacuum of space. Observing these distant objects is like trying to find a tiny firefly in a dense, dark forest. Yet, missions like NASA's New Horizons, which gave us a close-up view of Pluto and its neighbors, have started to lift the veil. Every discovery answers some questions while raising new ones, such as what forces shape this region and whether unseen planets could be lurking there. Scientists believe that billions of years ago, the migration of giant planets like Jupiter and Neptune scattered smaller objects, forming the vast and chaotic Kuiper Belt. This process explains its strange, tilted orbits and offers insight into the dramatic forces that shaped our solar system. The Kuiper Belt is a reminder of how much we still have to learn, holding the promise of discoveries that could reshape our understanding of the universe. It's the birthplace of short-period comets. The Kuiper Belt isn't just a distant icy frontier, it's also the birthplace of short-period comets. These comets, which return close to the Sun every 200 years or less, create the iconic bright tails that streak across the sky. When you see a comet like Halley's or Encke's, you're witnessing a cosmic visitor that began its journey in this distant region of our solar system. The Kuiper Belt is packed with frozen objects made of rock, dust, and ice, remnants from the formation of the solar system. Occasionally, the gravitational pull of outer planets like Jupiter and Neptune disrupts the orbits of these objects, sending them on a new path toward the Sun. As they approach, the Sun's heat vaporizes their icy surfaces, releasing gas and dust to form glowing comas and stunning tails. Each time you see a comet, you're witnessing the Kuiper Belt's icy fingerprints. Short-period comets follow predictable elliptical orbits within the plane of the solar system, unlike long-period comets from the Oort cloud that arrive from all directions. These differences offer scientists valuable insights into the forces shaping our cosmic neighborhood. Short-period comets are like ambassadors from the Kuiper Belt, giving us a glimpse into its icy world. Studying these comets unlocks the solar system's history. Their material, largely unchanged for billions of years, makes them time capsules from the dawn of the solar system. By analyzing their composition, scientists learn about the conditions that existed when planets were forming. The next time you see a comet lighting up the night sky, remember it's a traveler from the Kuiper Belt, carrying ancient stories from our cosmic past. The Kuiper Belt extends beyond what we can see. The Kuiper Belt extends far beyond what we can see, and its sheer size is mind-blowing. Imagine a region that begins just past Neptune, about 30 times the distance from Earth to the Sun, and stretches to nearly 55 times that distance. This colossal expanse is packed with icy worlds, dwarf planets, and countless smaller objects. What's even more fascinating is that this might just be the beginning. Evidence suggests the Kuiper Belt transitions into the scattered disk, a more distant and chaotic region, like the edge of a cosmic ocean fading into the unknown. Studying something so massive and distant is a monumental challenge. The Kuiper Belt's objects are small, dim, and spread out, making them incredibly hard to detect even with the largest telescopes. Yet, astronomers persist, uncovering new Kuiper Belt objects, KBOs, and piecing together a puzzle of the solar system's outermost frontier. Despite these efforts, the Kuiper Belt still holds far more secrets than answers. The greatest challenge in exploring the Kuiper Belt is its vast distances. The New Horizons spacecraft, which gave us a close-up look at Pluto, took nearly a decade to reach its inner edge. Exploring deeper into this icy region would take even longer, requiring extraordinary patience, planning, and technology capable of enduring deep space's harsh conditions. The Kuiper Belt is more than just a boundary. It's a potential key to unlocking the history of the solar system. Studying it might reveal how the planets formed and evolved, shedding light on mysteries we've pondered for centuries. Could there be a hidden ninth planet influencing the orbits of objects in this region? The Kuiper Belt sparks curiosity and pushes the boundaries of exploration, reminding us there's still so much about our cosmic backyard to uncover. Kuiper Belt objects may hold clues about Planet 9. Kuiper Belt objects might hold the key to solving one of the greatest mysteries in modern astronomy, the hunt for Planet 9. Imagine a massive planet lurking in the farthest reaches of our solar system, so distant and dark that we can't see it directly. Yet the strange orbits of certain Kuiper Belt objects, KBOs, are offering clues. These objects follow unusual, tilted, or clustered paths, almost as if they're being tugged by an unseen force, possibly Planet 9. Astronomers believe this hypothetical planet, potentially up to 10 times the size of Earth, could be hiding beyond the Kuiper Belt. Its gravitational pull might be influencing the orbits of KBOs, creating patterns that wouldn't exist otherwise. It's like ripples on a pond. You might not see the pebble, but the ripples reveal its presence. Similarly, Planet 9 could be revealing itself through gravitational ripples in the Kuiper Belt. The search for Planet 9 is a monumental challenge. The Kuiper Belt is vast, and Planet 9, if it exists, would be incredibly distant, dim, and slow-moving. Finding it is like spotting a grain of sand on a beach at night. Scientists are using advanced telescopes like the Subaru telescope in Hawaii to scan the sky, while also mapping KBO orbits to pinpoint where Planet 9 might be hiding. Every new Kuiper Belt discovery adds another piece to this puzzle, making the search one of the most thrilling in astronomy. If Planet 9 is found, it would completely reshape our understanding of the solar system. It could explain the strange behaviors of certain KBOs and offer insights into the formation of the solar system's outer regions. Even if Planet 9 remains elusive, the Kuiper Belt itself remains a treasure trove of secrets, reminding us of how much we have yet to uncover. The idea of a hidden giant lurking at the edge of our cosmic neighborhood is a thrilling call to explore the unknown. And just imagine what we might discover next. The Kuiper Belt could redefine the search for life. The Kuiper Belt might change how we search for life in the universe. For years, scientists have focused on planets in the Goldilocks zone, where conditions are just right for liquid water and life. But what if the secrets of life lie in the icy, distant reaches of the Kuiper Belt? This isn't just a region of frozen rocks and dwarf planets. It could harbor the ingredients for life, potentially reshaping our understanding of where life can exist. One exciting possibility comes from subsurface oceans. Objects like Pluto and its moon Charon might have liquid water buried beneath their icy crusts. Even in the cold Kuiper Belt, tidal forces and radioactive heating might keep hidden oceans warm enough for microbial life to survive. If Europa or Enceladus, moons closer to us, are considered potential hosts for life, why not similar objects in the Kuiper Belt? Adding to the intrigue are the organic compounds found on some Kuiper Belt objects. These complex molecules are the building blocks of life, suggesting the chemistry needed for life might exist beyond planets. Discovering such compounds frozen in time could offer a glimpse into how life began, not just on Earth but anywhere in the universe. It's like finding a cosmic time capsule, untouched for billions of years, that could unlock the secrets of life's origins. The Kuiper Belt challenges the assumption that life needs a warm, Earth-like environment to emerge. Signs of habitability in this icy frontier would force us to rethink where we search for life, making even the cold, dark corners of the cosmos just as promising as sunlit zones. The Kuiper Belt reminds us that the universe doesn't follow our expectations, and that's what makes exploring it so thrilling. That brings us to the end of our deep dive into the Kuiper Belt, a realm that continues to surprise and intrigue scientists with its secrets. From ancient relics of the solar system's formation to the tantalizing possibility of hidden worlds, the Kuiper Belt challenges what we know about our cosmic neighborhood. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep reaching for the stars and uncovering the universe's greatest mysteries. What if the universe ends tomorrow? No warning, no time to prepare, just gone. Sounds like a sci-fi movie, right? But here's the crazy part. Scientists actually have theories about how the universe could meet its ultimate fate, from a slow, icy death to a sudden cosmic collapse or even a reality-shattering event that happens instantly. These aren't just wild guesses, they're backed by physics. And the scariest part? Some of them could happen without us ever seeing it coming. So what's the truth? Let's dive into the ultimate doomsday theories and find out how everything we know could end. The Big Freeze. Alright, picture this. You're walking outside one night and for some reason the stars look dimmer. Not just one or two, all of them. The sky feels colder, emptier. Now what if I told you that this is exactly how the universe might end? Not with a bang, not with destruction, but with a slow, agonizing freeze. Scientists call it the Big Freeze or heat death, and honestly it's one of the scariest ways for the universe to go. Right now, our universe is expanding. Galaxies are moving away from each other like people trying to avoid an awkward conversation. But the problem? They never stop moving. Ever. The farther they go, the colder everything becomes. Stars will die, galaxies will vanish, and black holes will eventually evaporate, leaving behind a vast, empty, frozen void. Imagine the last star in the universe, flickering like a dying candle. No more warmth, no more light. Just eternal, infinite darkness. Even atoms might stop vibrating, meaning time itself could just stop. Forever. But here's the real kicker, this isn't something that happens in an instant. It's a slow, inevitable process that would take trillions upon trillions of years. So, if you're worried about waking up tomorrow to an ice-cold void of nothingness, don't be. We still have time, for now. The Big Rip. Okay, imagine you're holding a piece of paper. Now slowly, tear it in half. Now again, and again. Until there's nothing left. Now, apply that same concept to the entire universe, except instead of paper, it's planets, stars, galaxies, even atoms. Welcome to the Big Rip, a theory that suggests one terrifying possibility. Dark energy could one day become so powerful that it overcomes everything. Gravity, nuclear forces, even the very fabric of space itself. Right now, dark energy is this mysterious force making the universe expand faster and faster. But what if that acceleration keeps increasing? What if, in a distant future, galaxies are torn from each other? Then solar systems, then planets? Eventually, even your body would be stretched and ripped apart, atom by atom. And the worst part, scientists estimate that if the Big Rip is real, it would happen in a sudden, unstoppable chain reaction. First, galaxies separate. Then, black holes dissolve. Then, planets and moons start drifting away, until in the final moments, boom! Space-time itself is shredded, and the universe as we know it ceases to exist. So, while we might be safe for billions of years, if this theory turns out to be true, well, let's just say we won't see it coming. The Big Crunch. Alright, let's flip the script. What if, instead of expanding forever, the universe suddenly decided to reverse? Imagine watching a movie of the Big Bang, but in reverse. Galaxies stop moving outward and start falling back toward each other. Space itself shrinks. Stars collide. The entire universe begins to implode under its own gravity. This is the terrifying possibility of the Big Crunch. At first, it wouldn't be noticeable. The cosmos is vast, and these changes would happen over billions of years. But eventually things would get weird. Galaxies would merge in violent collisions, black holes would devour everything in sight, and temperatures would skyrocket as matter condensed. Now, picture the very last moments. Everything, stars, planets, dust, even light itself, squeezed into an unimaginable singularity. A point so dense, so hot that the laws of physics completely break down. Sound familiar? Yep. This singularity would look exactly like the one that started the Big Bang. Which raises the question, what if this isn't the first time it's happened? What if the universe doesn't just end, but resets? The Big Bounce theory suggests that once the universe collapses, another Big Bang could ignite a new beginning. A fresh universe with new galaxies, new planets, maybe even new versions of us. So is the Big Crunch the end of everything, or just a cosmic reboot? We don't know. But if history really does repeat itself, the universe may be stuck in an endless loop of birth, death, and rebirth. Kind of poetic, isn't it? Vacuum decay. Alright, this one is pure nightmare fuel. Unlike the Big Freeze or the Big Crunch where the universe takes billions of years to die, this could happen at any moment, without warning. Let me introduce you to vacuum decay, or as some physicists like to call it, the Big Slurp. Sounds funny, right? Yeah, not when you realize what it means. Right now our universe exists in what's called a false vacuum, kind of like standing on thin ice. It feels stable, but beneath us, there might be something more fundamental, something more real. If a quantum fluctuation or some bizarre high-energy event were to trigger a shift, a tiny bubble of true vacuum could form. And guess what? That bubble would expand at the speed of light. You wouldn't see it coming, you wouldn't feel it, it would just happen. 1 second the universe is here. The next, gone. The laws of physics would change instantly. Atoms would stop being atoms. Time and space would cease to exist as we know them. It sounds like sci-fi, but this isn't some horror movie plot, it's actual science. Some physicists believe that if the universe is truly in a false vacuum state, then vacuum decay is inevitable. The only good news? If it happens, we wouldn't have time to process it. No suffering, no pain, just poof. So, will we wake up tomorrow and find out the universe has been rewritten? Probably not, but the possibility alone is enough to keep some scientists awake at night. Sleep well. the big bounce. Alright, let's think outside the box for a second. What if the universe never really ends? What if, instead of collapsing into nothingness or freezing over, it just bounces back? Imagine a giant cosmic heartbeat, expanding, collapsing, expanding again. This is what scientists call the big bounce. It all starts with a big crunch, where everything gets pulled back together, condensed into a singularity. But instead of staying trapped, something triggers another big bang, a new universe bursting into existence, repeating the cycle all over again. And here's where things get really crazy. What if every new universe is just slightly different? Maybe in one version the laws of physics are the same, but galaxies form in completely different places. Maybe in another, the speed of light is different or gravity is stronger. And maybe, just maybe, there's another version of you out there living a completely different life. This theory makes the universe feel less like a one-time event and more like an eternal process. The end? It's just the start of something new, over and over again. And if that's true, then maybe this isn't the first time we've had this conversation. Maybe in some past version of the universe you've already heard this before. And maybe, just maybe, you'll hear it again. The role of dark energy. Okay, now let's talk about the real mystery here, dark energy. If the universe's fate is a movie, dark energy is the director. We can't see it, we don't fully understand it, but it's shaping everything. And depending on what dark energy really is, it could decide which of these doomsday endings actually happens. Right now, dark energy makes up about 68% of the entire universe. It's like a force that's pushing everything apart, making space expand faster and faster. But here's the scary part. We have no idea what it is. Is it a constant force? Will it get stronger? Or could it suddenly change? If dark energy stays constant, the universe might just expand forever, leading us straight into the big freeze. And if it gets stronger, we might be headed for the big rip, where space itself is torn apart. But if it weakens, gravity could take over again, pulling everything back for a big crunch. And here's something even crazier. What if dark energy isn't just controlling this universe, but all universes? Some scientists think that dark energy could be linked to the multiverse, meaning that whatever happens to our universe is just a tiny piece of something much, much bigger. So, will dark energy let the universe drift into an icy grave, rip it apart, or start the cycle all over again? The truth is, we don't know. But one thing's for sure, dark energy is the key to everything. So, is the universe destined for a slow freeze, a violent collapse, or something even stranger? The truth is, we may never know until it happens. But one thing's for sure, the cosmos is full of mysteries waiting to be unraveled. If you love exploring the mind-blowing possibilities of science in the future, make sure to subscribe to InnoVision Tech for more deep dives into the unknown. What do you think will be the universe's ultimate fate? Let's discuss in the comments. In 1960, two men descended nearly 36,000 feet into the Mariana Trench, Earth's deepest, darkest frontier. It wasn't just a dive, it was a plunge into the unknown, where light vanishes and pressure crushes steel. Even today, this abyss remains more alien to us than the surface of Mars. Despite decades of exploration, the trench hides secrets we've barely begun to uncover. Life forms defying logic, ecosystems untouched by time. So, if you were there, surrounded by silence and shadow, what would you feel? Let's uncover what really lies beneath the ocean's surface and why it still haunts human imagination. A journey into the abyss. Imagine standing at the edge of the world, staring into an endless blue void where the surface shimmers but the bottom remains hidden in pure darkness. Now picture yourself diving headfirst into that vast unknown, deeper and deeper until the sunlight fades away completely. And you're surrounded by a world so silent, so crushing, so alien, that it feels like you've left Earth entirely. Welcome to the Mariana Trench, the deepest, darkest mystery of the ocean. It's not just a trench, it's a gaping scar on our planet's surface, deeper than Mount Everest is tall. Few humans have dared to visit this hidden world. It's a place where normal rules don't apply, where pressure can crush a human-made submarine like a soda can, and temperatures are barely above freezing. But despite its terrifying reputation, the Mariana Trench also holds secrets. Secrets that could teach us about life in extreme environments, about Earth's past, and maybe even about life beyond our planet. Are you ready to journey into the unknown, where reality bends, and the impossible becomes possible? Because once you cross that invisible threshold, there's no going back. Let's dive deeper, both literally and figuratively. into this uncharted abyss where mystery reigns supreme and the ocean guards its darkest secrets. The geography and depth of the trench. If you pulled out a world map and looked east of the Philippines, you'd spot a small chain of islands, the Marianas. Hidden beneath these islands is something far more massive and mysterious, the Mariana Trench. Stretching over 1,580 miles long, about the distance from New York to Dallas, and around 45 miles wide, this trench is Earth's ultimate deep dive. But the real crown jewel of this abyss is the Challenger Deep, the deepest known point on Earth's seafloor. How deep is it? Try a mind-boggling 36,070 feet, that's nearly 7 miles down. To put that in perspective, if you dropped Mount Everest into the Mariana Trench, its peak would still be submerged by more than a mile of water. It's almost incomprehensible, right? Yet this trench isn't just a single dip, it's a dynamic landscape with ridges, valleys, and slopes sharper than anything we find on dry land. It's like an underwater Grand Canyon, but far more massive and far more terrifying. And here's something wild, scientists believe there may be even deeper spots nearby that are still unmapped. The trench sits in one of the most geologically active regions on Earth, constantly shifting, evolving, and hiding more mysteries under its crushing darkness. What secrets still lie hidden in those unreachable depths? We're just scratching the surface. Geological formation and features. Let's rewind the clock. Millions of years ago, Earth's surface wasn't the quiet, steady land we know. It was alive, shifting, groaning, and tearing apart like a living creature. That's how the Mariana Trench was born, out of a violent dance between two colossal plates of Earth's crust. Here, the mighty Pacific Plate is slowly but relentlessly diving beneath the smaller Mariana Plate in a process called subduction. Imagine one giant slab of rock sliding underneath another, disappearing into the molten depths of our planet. That sinking action carved out the enormous trench we know today, but it didn't stop there. The collision created an entire chain of underwater volcanoes called the Mariana Arc, a fiery, hidden landscape few have ever seen. Some of these volcanoes are active, constantly spewing minerals and gases into the deep sea. Others are extinct, sitting silently like forgotten monuments in the abyss. Strange features like mud volcanoes and hydrothermal vents, basically underwater geysers, dot the trench, pouring scalding hot water and strange chemicals into the icy ocean. It's a wild, alien world down there, sculpted by forces beyond human imagination. The ground itself creaks and shifts constantly. It's a reminder that beneath the calm blue surface of our oceans, a titanic battle is always raging, shaping our planet, one slow, invisible inch at a time. Extreme conditions. Picture yourself 7 miles underwater. It's pitch black. The cold bites at your skin, and every inch of your body feels like it's being crushed by a monstrous force you can't escape. Welcome to the reality of the Mariana Trench. Down here, the pressure is more than 1,000 times what you feel at sea level. That's like balancing 50 jumbo jets on top of you, at once. No human could survive it without heavy-duty technology. And if you think it's warm down there because of the volcanoes, think again. Temperatures hover just above freezing, a brutal, unforgiving chill that seeps into everything. The combination of crushing pressure and bone-numbing cold creates an environment that is almost completely hostile to life as we know it. Yet somehow, life finds a way. Specialized creatures have evolved biological superpowers, flexible bones, pressure-resistant cells, and metabolism adapted to an energy-starved world. It's almost like another planet right here on Earth. Scientists even believe studying these extreme conditions could unlock secrets about how life might exist on other worlds, like the frozen oceans of Jupiter's moon Europa. But for now, most of us can only wonder and respect the immense power of the deep. It's a world where survival means mastering the impossible, every single moment. Unique and mysterious life forms. You might think the Mariana Trench is a lifeless wasteland, but you'd be wrong. Down there, in the pitch-black cold and mind-crushing pressure, life has adapted in ways so bizarre they almost seem like creatures from a sci-fi movie. Meet the Mariana snailfish, the deepest dwelling fish ever discovered. It's small, ghostly white, and so fragile-looking you'd never guess it can withstand such unimaginable pressure. Then there are the amphipods, shrimp-like creatures that survive by scavenging whatever organic matter drifts down from the surface. Some of them are coated with strange, pressure-resistant exoskeletons that scientists are still trying to fully understand. And don't forget the xenophyophores, gigantic single-celled organisms that look like alien fossils scattered across the seafloor. These life forms thrive by embracing the impossible, enduring toxic chemicals, darkness, and crushing forces that would kill most other organisms instantly. What's even crazier? We've barely scratched the surface. Every expedition reveals new, unknown species hiding in the trench's hidden pockets and valleys. It's like a living, breathing mystery box, offering glimpses into how life can survive under the harshest conditions imaginable. Some researchers even believe that studying these creatures might offer clues to how life could exist in the icy depths of alien oceans across the galaxy. The deeper we look, the more we realize life is far more adaptable and more wondrous than we ever imagined. Human exploration and discoveries. For most of human history, the Mariana Trench was just a shadowy rumor, a place we knew existed but dared not explore. That changed in 1960, when Swiss oceanographer Jacques Piccard and U.S. Navy Lieutenant Don Walsh took a daring plunge aboard the bathyscaphe Trieste. In a cramped steel sphere barely big enough for two, they descended nearly 36,000 feet into the Challenger Deep. The pressure outside was so intense that the tiny windows cracked, but they made it, witnessing a seabed covered in thick silt and strange creatures. Fast forward to 2012, when filmmaker James Cameron, yes, the Titanic and Avatar director, made a historic solo dive, reaching the Challenger Deep in his specially designed submersible, the Deep Sea Challenger. Cameron's journey wasn't just for glory. He brought back three-dimensional footage, valuable scientific samples, and new discoveries that rewrote our understanding of the deep sea. Since then, unmanned submersibles and robotic vehicles have continued to probe the trench, discovering ecosystems fueled by chemical reactions rather than sunlight. But here's the wild part. We've explored Mars and the Moon in greater detail than we have explored the Mariana Trench. So while we've made historic strides, the trench remains a realm of mystery. Who knows what still lurks in its deepest shadows, waiting for the next brave soul to uncover its secrets. The future of deep-sea exploration. The Mariana Trench is not just a relic of Earth's past, it's the frontier of tomorrow's discoveries. As technology advances at lightning speed, our ability to explore these crushing depths improves, opening doors to mysteries once thought unreachable. New autonomous underwater vehicles and robotic submarines are being designed to withstand extreme pressure and dive deeper, longer, and with better precision than ever before. Scientists are gearing up for missions that could reveal unknown species, uncover rare minerals, and even shed light on how life can survive in the most hostile conditions. These explorations could have far-reaching implications, not only for oceanography but for medicine, biotechnology, and even the search for life beyond Earth. However, this exciting future also comes with responsibilities. The push to explore must be paired with careful stewardship to avoid damaging these fragile ecosystems. The choices we make now about how we explore and protect the deep ocean will shape what future generations inherit. The Mariana Trench stands at the crossroads of science, technology, and ethics, reminding us that the final frontiers of our planet still hold secrets, and the chance to inspire humanity's imagination and respect for nature in equal measure. Thank you for diving deep with us into the hidden world of the Mariana Trench. It's incredible how much mystery still exists right here on our own planet. What do you think could be lurking in the parts we haven't explored yet? Share your thoughts in the comments. We'd love to hear them. This is InnoVision Tech, bringing you closer to the wonders of science and exploration. And if you love discovering the mysteries of the universe and space, don't forget to like, subscribe, and hit the bell icon for more adventures.